Hello. I'm gonna just wait for a couple people to join. Hi everyone. So today we're gonna be doing a chemistry paper one. I'm just waiting for a couple more people to join and then we'll get started. All right. So for chemistry paper one, we're doing a standard level paper and it's gonna be from M23 Time Zone 2. Okay. How you guys feeling about exams? Let me know. Is everyone stressed? Is everyone confident? We're gonna start in like 5 minutes. You're so scared? Yeah, how are you guys preparing? Are you like using your notes, flashcards? You have math first. I think I also had math first, which was terrifying. No, I had English first actually. It is very scary. All right, we're gonna start very, very soon, guys. Start at like 5:40 or 4:40 if you are in the UK. Hello, hi everyone. Math, the only problem, everything else is easy. Which science do you do? Can we have a bio SL paper again, please? Well, if enough people request it, then um, we're more than happy to do one. All right, hopefully you guys can see my screen and everything is good. So as I said, this is a M23 Time Zone 2. So if you guys can also download the paper or just get ready to take notes, basically. Start in 2 minutes. Thank you so much. Someone said they really appreciated last time's paper. Thank you guys. Is it true that November exams are harder than May exams? I think can't like ignore my focus. I think there are a bit more difficult, but again, it depends on like what you find as difficult. Um, yeah, someone said yeah, they also think that way. I think so too. When I was doing my past paper practice, I also found it that way. Okay, 2 more minutes and we're starting, guys. Get ready with a pen and paper. Do you find it easier to get a 7 in paper one and paper two? I hate paper one. I love paper two just because um, paper one, I don't know, they complicate the questions so much. And also, I feel like paper one, you don't have enough time. Paper two, you get to like take your time and finish the question. So paper two is much easier for me. When we do HL bio, the HL bio we actually did with the crash course, but we did do the SL bio, and it is on our YouTube channel if you missed that one. And someone requested another session, we could have one if enough people request it. All right, 1 more minute. 1 more minute and we're starting. Has everyone started studying for chemistry or not yet? Hopefully some people have started. For ChemHL, can you do paper 3 option C? We'll show you guys a feedback form at the end of the live, and then you guys can request as many things as you want. So some people have not started, some people have. That's completely normal. You can start at your own pace. Just make sure to start soon. All right, let's get started because we don't want to waste any more time. But this is a paper one and it is an SL, so it's out of 30 marks. So you only have 30 questions rather than 40 compared to HL. And it's worth 20% of your grade. Okay, so if you fail paper one, you still have paper three to save you, so you'll be fine. So make sure you learn your option topics well. You can join our option crash course if you like. As with any paper one, you get a periodic table at the beginning. Okay. First question is I'm gonna read the question out, give you guys a couple of seconds to answer in the chat, and then I'm gonna go ahead and answer it with you. But the first question says, which is the correct equation for the electrolysis of molten sodium chloride? So it's molten I'm going to give you guys a hint, not aqueous. How would you guys answer this question? I'm going to wait till I see some answers in the chat and then I'll go ahead and answer it. Someone said, thank God I don't take chemistry. Okay, so what are you guys thinking for question 1? This is part of topic 8, so redox. Someone said they think the answer is C. Okay, C, C, C. C. Very close answer, guys, but actually A is the correct answer. But I can see where you guys got C from because very, very close. So the keyword here is molten, so it's not aqueous. So we can already cross out it's this one here with the AQ because it's not aqueous. And then also for B, it's solid, and we know for molten, it's like melted sodium chloride, so we can also cross out B. And then we're left with NaCl and so options A and C. And we can see that NaCl is both liquid in both of them, so those are still both of our options. But what actually allows us to eliminate C is because it shows us that Na forms a solid. So it cannot be C because Na during molten sodium chloride will actually be formed as a liquid. But you guys were correct to say that chloride, so chlorine is released as a gas, correct? But um, that differentiating factor between A and C would be that Na is released as a liquid, not a solid. And if you guys have difficulty doing that, visualizing that, I would suggest maybe watching a quick video about the electrolysis of molten sodium chloride. And our tutor actually heavily goes into explaining the difference between each of the electrolysis and so on. Electrolysis, voltaic acid, voltaic cells, and so on in our crash course. So I would suggest watching a video because videos are really what helped me. All right. Question 2. What is the mass of one molecule of C60? And this was also on the HL paper, and I remember when I opened this for my exam paper, I had a mini panic attack because I've never seen C60, but I promise you it's a simple question. So what are you guys thinking? I'm going to give you a bit longer to answer this one because it does involve calculation. Okay? Let's see here. So put your answers in the chat. Someone said we're cooked. You guys almost gave the correct answers. It was very good try. If you don't know the answer, just guess maybe. Someone said D. And maybe what could be helpful is giving writing down an explanation of why you think it's D in the chat, and I'll read it and tell you if it's correct. So that way you can get you can like kind of practice explaining why your answer is correct. Okay, so I'm getting a lot of D's and B's, and whoever said D, and I see a lot of you guys actually said D, you are correct. And you have to use the Avogadro triangle and the mole triangle. So it says, what is the mass of one molecule of C60? Well, I know that moles equals grams over molar mass, and I'm trying to find the grams. So I do the moles times the molar mass equals my grams. How do I find the molar mass? Well, I know the molar mass of carbon is 12, and I know that there's 60 carbon atoms, so it's going to be 60 times 12, and that gives me actually 720. So I found the molar mass 720, and now I have to find the moles. And to find the moles, this is where I use Avogadro's triangle. And Avogadro's triangle states that if you have one molecule, you divide that by Avogadro's constant, or 1 divided by 6.0 times 10 to the 23. That will equal to your moles. Does that sound familiar, guys? Right? Okay, so now that I've found the mole number, I can just substitute it back into this equation here to find the number of grams. So it will be 720 divided by 6.0 times 10 to the 23 equals the grams. And the next step, I'm actually going to go ahead and write it a little bit further here in this question so you guys can see it better. But what I do is I'd like to convert my numerator in terms of 10 times something. So in terms of scientific notation. So to do that, I just do 7.2 times 10 to the 2. That's the same thing as saying 720. And then 6.0 times 10 to the 23. So someone asked, how would you do this without the calculator? It is really annoying, but the first step would just be converting it to scientific notation. And then I can do 10. So do you guys see how this says 10 to the 2 and this says 10 to the 23? And when you have two things with exponents that are divided on top of each other, just like you do in math, you subtract them. So you do 10 to the 2 minus 23. You with me, guys? And then that will lead you to an answer with 10 to the negative 21. And that's how I know my answer is D. My answer is D because I can clearly see it's the only one with the power of 10 to the negative 21. All right. And then also 7.2 divided by 6, that's going to give us around 1 point something. So it makes sense why it's definitely not C because 8 would be too high. It's definitely not, it could be 2 because it's kind of close, but remember 12 over 6 would give me 2, so it can't be B. And then what differentiates between A and D is again the scientific notation, and we know 7 divided by 6 is going to be a little bit higher than 1. Okay? So that's why our answer is D. Hopefully that made sense, guys. Please ask any questions in the chat if you want me to rework out the question or want any clarification of anything. I'm just going to move this here so we can move on to the next question. Someone asked, is this SL or HL? It is SL. What's your best tip for chemistry? I think is just do as much past papers as you can, so you can get exposed to all the different types of past paper questions they can ask you, because sometimes they'll bring up a new question that is something that you do know, but it's formatted differently. So being exposed to that question before you enter your exam can be very, very helpful. Someone's asking, how do you get past papers? You can find them on Reddit. Okay, let's move on for the sake of time. Question 3 is, it looks hard, but I promise you it's simple. So it says 20 centimeter cubed of gas A reacts with 20 centimeter cubed of gas B to produce 10 centimeter cubed of gas AX BY and 10 centimeter of excess gas A. What are the correct values for the subscripts here in the empirical formula of the product AX BY? So I'm going to give you guys a couple of seconds to try to answer this in the chat, and I'm going to draw the equation of what we're actually trying to figure out. So we have A plus B equals AX BY, and that leaves me with excess gas A. So I have 20 of this one, 20 of this one, and I have 10 remaining of this one. I'm going to give you guys a couple of seconds to give me some answers in the chat. Okay, I already see a D in the chat. What is everyone else thinking? Have all the questions been always the same? So they're not repeated exactly like with the numbers and everything, but they're formatted the same. They're very similar. All right, a lot of people are putting D in the chat, and if you did put D, you are correct. I'm going to explain why it's D. So D is the correct answer. So the first step for this type of question is I would always suggest to rewrite the equation like this, just like I did. A plus B equals the product plus the excess reactant. Okay, and it's telling me that I use 20 of A and 20 centimeter cube of B, and I'm left with 10 centimeter cubed of A. So what does that mean? That means that I've only used 10 centimeters of A. I've used 10 centimeters of A in my product because 10 was remaining, okay? And I can see here that there's no remaining, any product remaining of B. So that means I've used all of B. So I've used all of the 20 centimeter cubed of B. So I've used 10 of A and 20 of B. So that can tell me, you can see, I can sort of build a ratio. I've used 10 to 20 ratio, and that's the same thing as saying a 1 to 2 ratio. So my A and X, AX will be A to the 1, and B will be to 2. Does that make sense, guys? Can you see how I made that connection? So that's why our answer is going to be B, because X is 1 and Y is 2. I'm going to give you a couple of seconds to digest this question because I know it's a bit difficult, but hopefully you guys were able to work it out with me. Someone said they don't quite understand. Of course I can repeat. All right, so let's start from the beginning. It says 20 centimeter cubed of A reacted with 20 centimeter cubed of B to form a product and 10 centimeters of excess A. So if I started with 20 centimeter cubed of A and I'm left with 10 centimeter of excess A, how much A was used in the AX plus BY? So only 10 of A was used. Correct. So I can say that only 10 was actually used in here because 10 was left out to be remaining. All right. Does that make sense so far? Just let me know if that makes sense so far and then I'll move on. Okay, someone said yes. So only 10 of A is used. Exactly. Perfect. And I can see that there's no excess of B. There's no B given to me in the question that was not used. So I know 100% 20 of B was used. So if 10 of A was used and 20 of B was used, that means I have a 1 to 2 ratio. So my X value is going to be 1 and my Y value is going to be 2. That's why it's going to be D. So how is the Y? You get it? Okay, perfect. So does that make more sense, guys? Do you guys think you'd be able to answer this by yourself? Hopefully the answer is yes after doing this. Yes? Okay, perfect. Let's move on. So this one was also on the HL paper, and when I saw this, I also had a mini panic attack because I hate graphs and learning about the relationships with graphs. But let's read it. I promise you it's not as complicated as it looks. So it says the volume for a fixed mass of an ideal gas was measured at a constant temperature at different pressures. Which graph shows the correct relationship between PV against P? I'm going to give you a couple of seconds to try to answer this one in the chat. All right. Give me some sample answers in the chat. Okay, someone said A. Why do you think it's A? Or why do you think it's C? Try to reflect on it. Try to give me some reasoning. Someone said, is this SL or HL? It's SL. Okay, I'm getting a lot of A's and C's. Okay, let's work this out. So the graph basically wants me to measure PV over P. Okay, that's the first step. I always like writing out my graph relationships in terms of fractions. So I can clearly see that it wants me to measure the graph of PV over V. And actually, guys, if you notice that we have the same number in the numerator as we do as in the denominator. So what I can do is I can just cancel out my P's and I'm left with V. And V is a constant. So that's why my answer is going to be A. Does that make sense, everyone? Hopefully it makes sense. It's very simple. It looks complicated, but it's simpler than it seems. Someone sent me a heart. Thank you very much. That's very cute. Is this gas laws? Yes. But this is not one of the gas laws you were required to memorize. But basically, they're just testing your ability to like analyze graphs. I think more likely in this question. So you were not expected to know this entering your exam, and I didn't know it entering my exam. But using like math, I was able to cancel out both my numerator and my denominator, and therefore I got V. Is this the new syllabus? No, it's an M23 past paper. All right. But for all this knowledge is also on the new syllabus, so if you'd like to stay and you're from the new syllabus, you can. Okay. Question 5 says, what is the correct ground state electron orbital configuration for 2s2p2? Is this HL or SL? It's SL. So I'm getting an A in the chat. I'm getting lots of A's in the chat. A. Very good, guys. I'm very happy that most of you have gotten A. Also, just write down a little explanation why you think it's A, but you guys are very, very correct. And I'm going to work through a process of elimination with you guys to make sure that you guys understand why everything else is incorrect. So B is definitely incorrect because I can see that my electron are facing the opposite directions, and that's incorrect. They initially face the same directions. Everyone's putting A. I'm very proud of you guys. And here we see that there's an issue with C because here we can see that they're facing the same directions, and that's incorrect. And then finally, we see the same issue of them facing the same directions here, and then the opposite directions here, which is also incorrect. That's why our answer is not C, B, or D. All right, perfect. Um, Someone gave their explanation, said it's the distribution of electrons on the orbitals. Correct, exactly, guys. The following diagram shows a light passing through a cold gas cloud and a light from a hot gas cloud. So this shows a light source, and it's a cold gas cloud, and this is a hot gas cloud. Which types of spectra are associated with light passing through a cold gas cloud? So that would be spectrum A, and light from a hot gas cloud. So that would be spectrum B. So if you're asking what unit question 6 is from, I think it's from unit 2 because it's all about the absorption and the emission spectrums. Okay, what are you guys thinking? And I think for this one, it's just a matter of memorizing. So you just have to memorize um, which one is absorption and which one is emission. And someone said they think it's A, A. I'm seeing A's in the chat, which is very good, guys. You are correct. It is A. And you just have to, it's a matter of memorization. Just memorize that spectrum A, cold gas, is always going to be absorption. And it says, what is the electron configuration of an element in group 4, period 5? I'm going to give you a couple of seconds to give me some answers in the chat, and hopefully you can see. I'm just going to zoom in a bit so you guys can see better. And this is going to be, of course, easier to answer when you have the periodic table, but let me draw you a sample periodic table here so it can kind of help you guys. Okay. Can anyone guess in the chat what it is? So something of group 4 is going to be in 1, 2, 3, the fourth group. So I know it's going to be somewhere in this one right here. And period 5 is 1, 2, 3, 4, 5. So fourth group in period 5 is going to give me this element here. And it would be much simpler if you had the periodic table, but I don't want to scroll all the way up. But that means that I'm going to have a 5s, so it's going to be 1s2, 2s2, 3s2, 4s2, so it's going to be 5s2. So I know that my element has to be involved in a 5s2. So I can cross out my B's and my C, and I'm left with D and A. And I already see the correct answer in the chat. I see a lot of the correct answer. You guys are correct. It is A. And the reason that is because it's going to be 5s2, and then 4d1, and then 4d2. So this is the correct one, 42. Okay. A, very good, guys. All right. Which properties increase down the group 1 alkali metals? So again, this is sort of a matter of memorizing the periodicity. So how do the melting point, the electronegativity, the atomic radius change when we're looking at the periodic table in general? Okay. So I'm seeing a lot of B's in the chat. Okay. I'm going to draw the sample alkali metal here for those who are having a bit of trouble understanding, but I can see that as I decrease down the group, go down the group, not decrease down the group, as I go down my group, my atomic radius does increase. Okay, does my melting point increase? My melting point actually decreases, guys. And then my reactivity with water, you guys are correct. The answer is B. It is reactive with water. Okay? The reactivity of water does increase as I go down my periodic table. Someone said, is this for DP? Yes, it is. Okay, hopefully that made sense. It's a pretty straightforward question. But if you got the question wrong, I think you just need to review your topic 3. Okay, it says, which compound is both volatile and soluble in water? I'm gonna give you guys a couple of seconds to guess. Are the live videos saved? I think they will be saved and uploaded on YouTube, hopefully. Okay, I'm getting C, which is very good. Very proud that you got that. Hi, Chloe. Okay, A, C. Okay, if you guys put C, it is SL by the way. If you guys put C, you are correct. The answer is C. And if we draw out actually the molecule, so CH3, 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 and then OH, I can see that clearly this one is soluble in water because it can form hydrogen bonds with my water molecule. Someone said, what's volatile? Volatile basically describes how easy an element, or sorry, a molecule is able to evaporate. So which one can evaporate and which one is soluble in water? Someone said also low boiling point. All right, and the answer would be C. You guys are correct. And you can see the OH group is what makes it soluble in water because it's polar and so on. Okay. Next question I think is much more simpler, but it says, which are the correct sequences of increasing bond strength and bond lengths between two carbon atoms? Someone asked, I think for the previous question, why it's not A. Well, the reason why it's not A because NaCl actually has very strong ionic bonds. And it's very polar, so when it bonds with something else, it has a high boiling point, and therefore it would be less volatile. Could you do bio? We've already done a bio live. You can see it on YouTube. Someone asked, what does volatile refer to? So again, it's how easily or if my molecule is easily able to evaporate. So break up and evaporate. Okay, let's move on to question 10. So again, which are the correct sequences of increasing bond strengths and bond lengths between two carbon atoms? Can anyone have any, can anyone guess any of the options? So someone said C. I'm getting a lot of C's. Very, very good, guys. The answer is C, but I'm going to draw it out to help you. Okay, everyone's saying C. I'm very, very proud. So I'm going to quickly draw it out. But let's do bond length first. So my C and single bond will be my longest. Then my double bond will be my second longest. And finally, my triple bond will be the shortest. And that concept is basically reversed when we're referring to bond strength. So the triple bond will be my strongest, my double one will be the middle, and my single will be the worst in strength, so it'll be the weakest. Okay, I'm very, very happy that you guys were able to answer that. Okay, next question, sorry, says, question 11 says, what is the electron domain geometry of sulfur dioxide? So if you have a piece of paper open, try drawing out sulfur dioxide. And remember, it's the electron domain geometry. You can find the past papers on Reddit. Why is the triple bond the shortest? Because you basically have much more electrons here. You have to hold the bond stronger. If you search it up on Google, you'll see that generally triple bonds are shorter. Well, here they have less attraction, so they're further away. Someone said tetrahedral, okay. And then someone said A or B. Okay, so the actual answer is D, but very good guesses, guys. I think it's just a matter of drawing it out fully. So let's draw out sulfur dioxide. So you can actually draw out sulfur dioxide like this. And there's a lone pair. Does everyone see why it's trigonal planar? Why the electron domain geometry is trigonal planar? Because I have one domain, two, and three, and that's why it's trigonal planar. Is this IB Bio? It's IB Chem. Okay. So when you're looking at the electron domain geometry, you're just looking at how many basically things are bonded to my central atom, and it's 1, 2, 3. It's SL. What about the electrons around the oxygen? What are you referring to? So I did draw the electrons around the oxygen here and here. This is M23. All right, does that make sense, everyone? They don't count as domains. So when you're looking at the domains, you're looking at them with reference to your central atom. Yeah, you only look at the central atom. Exactly. Very good, guys. Okay. I'll move on to the next question. We're almost halfway there, so that's pretty good. So it says, what is the correct comparison of my H to NH bond angles in NH2 minus, NH3, and NH4 plus? I'm going to give you guys a couple of seconds to guess, and while you're doing that, I'm going to go ahead and draw the... So this would be my NH2 minus. This would be my NH3. And finally, this would be my NH4 plus. Okay. I see a lot of people guessing A, and you are correct, because we can see that this is bent, so it has a bond angle of, 105. And then this one has a bond angle of 107. Let me do it in the same color so it's clear, 107. And then finally, this is tetrahedral, which is 109. So I can see that the NH4 plus has the highest, then it's my 107, and then finally it's my 105. Okay? Perfect. This one is a tricky question, and if you pay close attention to what the question is asking you, you should be able to answer it correctly. But it says the enthalpy of formation of ammonia gas is negative 46 kilojoule per mole. What is the energy released in kilojoule for the reaction? How do you know when it's bent or linear? So linear will bent is because it has um, two lone pair of electrons here. So you can actually write it out like this. You can draw it out like this. So okay, I'm getting a lot of D's. That's very good, guys. I'm very happy with your answers. And why is it D? Can someone tell me in the chat? Because this is a trick question. Well, something you do have to know and memorize is the definition of the enthalpy of formation. And the enthalpy of formation is the formation of 1 mole, right? But I can clearly see here in my equation that there's 2 mole of NaH3, and therefore I have to multiply my enthalpy of formation by 2, which gives me 92. Very good, guys. Your explanations are spot on. Okay, question 14, almost halfway there. So one more question, we're halfway there. It says, what is the delta H in kilojoule for the reaction of N2H4 plus H2 to form ammonia gas? Will you do a paper 2? The paper 2 is part of the crash course, but if you guys request it enough, I'll put a feedback form at the end. And depending on what people request the most, we will provide, because we're just trying to help. So if you guys would like a paper 2, fill out the feedback form and let us know. All right, what is everyone thinking for question 14? So remember, you have to look at each of the equations separately. I'm going to give you a couple of seconds to answer this one. Okay, I'm getting a lot of A's, and if you said A, you are correct. So let's look at the equations separately and see why the answer is A. So for the first one, I can see that my N2H4 here is also in my final reactant on the reactant side, and therefore I don't have to flip this number, and I don't have to divide this number because it is in 1-to-1 ratio. So I can do negative 37. Okay, let's look at our second question. Our second one says N2, H2, and 2NH3. And I can see that my NH3 is on my product side, and in my final one, it's also on my product side. And therefore, I don't have to flip my sign, so I don't have to flip my number, and I can see that the mole ratio is exactly correct, so I can just do plus negative 46. Okay, and finally, I have to look at the final equation, and I see that I actually do have to flip this number, so I do have to make it to positive 65. And why do I do that? Is because I want my, let me color it in for you guys so you can see. I want my CH3OH to be on the other side. I want it to be on my product side. And why is that? Because I want my CH3OH to cancel out with this one here. So what I'll have to do is flip the number to a positive sign. So it will be plus 65. Okay? Negative 37 plus negative 46. Can anyone tell me what that is? In the chat. Negative 83. Okay, so plus 65 will give me a final answer of negative 80. Someone said, is it important to be able to draw Hess's law? I think it is important. For example, in the HL chemistry paper 2, you actually did have to draw it. But that's more with like Born-Haber cycles and like lattice enthalpy. So if you're HL, I think worry more about it, but if you're SL, don't worry too much about it. Okay? All right. I'm going to move on to the next question, and this question's pretty simple. It says, which statement concerning bond breaking is correct? So, what is bond breaking? Is it endo or exo? Okay, I'm getting a lot of, someone said endo, and I'm getting a lot of A's. So if you did say endo and if you did say A, you are correct, because bond breaking is endothermic. And I actually draw a bond for you guys here to see. In order to break this bond into two separate molecules, what I have to do is use energy. So it requires energy, and therefore bond breaking is endothermic. I have to put a lot of energy into breaking it. Everyone's putting A's in the chat. Very good, guys. All right, let's do this one. It says, curve X on the following graph shows the volume of oxygen formed during the catalytic decomposition of a 1 mole decimeter cubed, so this is a concentration, of hydrogen peroxide. Which change would produce the curve Y? I'm going to give you a couple of seconds to try to reflect on this, and then we'll answer it together. What level is this? This is SL. B. If you did say B, you are correct. So very, very good job, guys, if you said B. But it is a difficult question, but let's work out and see why it's B. So if you add water, will that change anything on the speed of my reaction? Because I can tell in curve Y that my reaction actually happens much slower, and the amount of products I produce is going to be much higher. So adding water is not going to really change the speed of my reaction and the amount of products formed. Okay, so it's definitely not A. Let's look at C. So C says adding a higher concentration of hydrogen peroxide. Now, adding a higher concentration of hydrogen peroxide, that will cause my graph to actually go much, much faster. Because we've learned from topic 6 that if you increase the concentration, we have a much, much faster rate of reaction. So it cannot be C as well, because this would actually cause my graph to go much faster. Okay, And then finally, it says repeating the experiment without a catalyst. So I know the catalyst actually speeds up my chemical reaction. So it speeds up. So again, I would see a graph that would occur much, much faster. Um, and the catalyst doesn't affect the yield of the products. It doesn't affect how much products I'm forming. So it definitely cannot be D. Now, why is it B? Well, if I add a smaller concentration of 0.1, so 0.1 is smaller than my 1 mole, 1 mole decimeter cubed, that's why my reaction is going much slower because the lower concentration. And since I'm adding that to my solution, I'm actually increasing the number of moles. So therefore, that's why I'm having a much higher product yield. Okay? If this question's a bit difficult, then I would suggest just doing the process of elimination that we did. So it's definitely not water. It's definitely not adding a catalyst, and it's definitely not increasing the concentration because they all would show us a graph that shows like this. Why wouldn't water affect the speed? Why would water affect the speed? That's a question I would ask you. Why would you think water would affect the speed? Why would water affect the speed? That's a question I would ask you. Why would you think water would affect the speed? Wouldn't water dilute the concentration? So water, if you do, if you add water, distilled water, it actually doesn't have any. It doesn't react with my what's it called? It doesn't react with my reactants. If you add water, it's gonna shift. Yeah, but this is not an equilibrium. So someone said it might shift the equilibrium to the right, but we can see that it's not in equilibrium, and that's why we don't have those arrows like this. So it was a good guess, but it's not exactly correct. So just think back to all those experiments you did throughout IB in chemistry class. And do you guys remember how you guys would just add water and it would have no effect on your reaction? Why is the answer not C? Well, C actually shows a higher concentration. And you guys remember that when I have a higher concentration of hydrogen peroxide or a higher concentration, that causes my rate of reaction to increase because I have more particles to collide together, and therefore it would not show a decrease in the rate of reaction, it would show an increase of the rate of reaction. Okay? Does that make sense, guys? So it's not a catalyst because that would increase. It's not an increase in concentration because that would increase the rate of reaction, and water would have no effect. Okay? Okay, good. All right. Moving on, question 17 says a potential energy profile is shown for the reaction. Which energy changes would a catalyst affect? I'll give you a couple of seconds to answer this in the chat, and then we'll work it out together. And I'm going to give you guys a couple of hints while you're doing that. What does 3 represent? 3 represents our delta H. Is a catalyst ever going to affect our delta H? And I'm very happy you guys are putting lots of A's in the chat. That is the correct answer. Our delta H is not affected by a catalyst. But my 2 is because 2 represents the activation energy, and actually my activation energy is lowered. And if my activation energy is lowered, it's going to show like this in my graph. And that means also 1 is going to change, right? Because now it's going to go like this instead of previously it was like that. Okay, that's why my answer is A. All right. Okay, next question says, which condition will cause the given equilibrium to shift to the right? So now we're doing equilibrium questions. I can see my screen is a bit frozen, so just give it a second to load, guys. Um, Okay, so let's see here. Try reading the bottom of that question. I don't know if you guys can see that while we're waiting. Oh, there it is, it loaded. Okay, it says, which condition will cause the given equilibrium to shift to the right? I'm going to give you a couple of seconds to answer, and then we'll go ahead and answer it together. So what are you guys thinking? If you don't have an idea, just guess. You have a 25% chance of getting it right. Okay, a lot of people are saying C in the chat, which is very, very good. That is the answer. Which past paper is this? This is the M23 SL paper, paper 1. Okay, and you guys are correct that it is C because when we add solid NaCl to my aqueous solution, so I'm adding solid NaCl to my aqueous solution, my solid will actually split up to Na, will dissolve to Na plus and Cl minus, and then that's the same thing as increasing the Cl minus concentration. Okay, so if I increase the Cl minus concentration, that will cause my equilibrium to shift to the right, and you guys got it exactly correct. Very good, guys. Okay, next question, question 19 says, which reaction represents the neutralization of a bronzed-Lowry acid and base? Okay, I'm already seeing a B in the chat. B, B, B. Okay, I'm seeing a lot of B's, and you guys are correct. You guys have to remember that in neutralization reactions, I have an acid plus a base, which will form a salt and water, right? You do have to memorize this, unfortunately, because it's very, very common. And let's just look at the sample equations, at the sample answers, and eliminate them just based on that information. So we know it can't be A because A doesn't produce water. We know it can't be D because also D doesn't produce water, and this is not a salt. And you can kind of already take a guess and eliminate C because this is also not a salt. But let's reflect on what's the definition of bronzed-Lowry acids and bases. So if you could quickly type in the chat what the definition is, but a bronzed-Lowry acid and a base are H plus donors plus H plus acceptors. And we can see that here the H plus is donated from the HCl and given to the O to form H2O. And then the Cl then reacts to form a salt with zinc chloride. Very good, guys. Proton donor and proton acceptor. I'm going to move on because I think that everyone got this question correct, so I'm very happy. Okay, next it says, what is the hydroxide ion concentration in a solution of pH 4 at this temperature? So pull out a piece of paper and a pen and try working this out. And I think the key hint here is that a hydroxide ion. So don't get your H pluses and OH minus is confused. This is a hydroxide ion. What is the concentration of it? I'm getting a lot of D's in the chat. Very, very good, guys. The answer is D. Why is it D? Well, we can find so the pH plus the POH is going to give me pH of 14. So then I can go ahead and sub in the pH of 4 because it's given to me in the question, plus the POH is 14. So my POH will equal to 14 minus 4, which will give me 10. So now I know the POH is equal to 10. And does anyone remember what equation we use after this to solve for the hydroxide ion concentration? So the equation you use is POH equals negative log 10 to the OH minus. Very good, guys. Everyone's putting the equation in the chat. So then I can just substitute my value of POH equals negative log 10 OH. I'll move my negative to the other side, so negative 10 equals log 10 OH. And just by using logs from our school knowledge, our math knowledge, we know that that means it's 10 to the negative 10 equals OH, right? And so therefore my answer is D. This is SL. Why isn't the POH put 4? So the pH is 4. You have to be very, very careful. The pH is 4, but the POH is 10. Because you have to do 14 minus 4 to get the POH. Maybe I'll zoom in so you can see that better. Okay. All right. Next it says, which element has variable oxidation states in its compounds? So what do we know about variable oxidation states and what do they when do they happen? And it is a bit of a difficult question. So I'm going to give you a couple of seconds to answer. Okay, I'm getting a D in the chat. B, C, D. Okay, if you did say D, you are correct. The answer is D. And why is it D? Well, we know variable oxidation states happen when I have electrons in my D orbital. And I know that these are not transition metals, and actually in SL you don't have to worry about transition metals. Just know that variable oxidation states happen when I have electrons in the D orbital. And if we actually take a look at the periodic table, so give me a second to just pull up the periodic table, guys. Here, I know it's a bit lopsided, but we can see that potassium, which is here, has no D orbital electrons. Calcium has no D orbital electrons. Chlorine also has none, but bromine does because, it has all these electrons in its configuration. All right. Almost done, guys. We have about 8 questions left, which is really, really good. Okay, it says, which chemical process would produce a voltaic cell? So is it spontaneous, non-spontaneous? Is it redox or non-redox? Getting a lot of A's in the chat, and if you did say A, you are correct. Voltaic cells are actually spontaneous reactions. Electrolytic is non-spontaneous. So this is just something you do have to memorize. And voltaic cells are redox. So you can already eliminate the non-redox options. And we know that electrolytic are non-spontaneous, but voltaic are spontaneous. So that's why our answer is B. Question 23. I'm very happy with the way you guys are answering stuff. You're doing very, very well. And I can see you're getting most of the questions right, which is very good. Question 23 says, which species could be reduced to form SO2? I'm going to give you a couple of seconds to answer in the chat. And then we'll work it out together. So I'm getting A, C, B. So we're getting mixed answers, and that's okay. But basically, you have to calculate the oxidation states and compare them. So if you did say C, you did get the correct answer. I'm going to explain why. So remember oil rig. So oil rig stands for oxidation is loss and reduction is gain. You can see that my screen is lagging, so I'm going to wait a couple of seconds. Oh, there it is. So oxidation is loss, reduction is gain, and that stands for if it's gaining or losing an electron. So in this case, we want to see which is reduced. So we're looking for which ones gain. So have an increase. Let me say increase in oxidation number. Okay, so which ones have an increase in oxidation number? I have to calculate the oxidation number of SO2 first so I can compare it to my rest. So SO2 is going to have a +4. It's going to be -4 for the O and then +4 for the S. And then we know our elements have an oxidation state of 0, so it can't be A. Let's look here. I know it's going to be, my S is going to have a +4. So actually I can see that my oxidation number does not change. So it's definitely not going to be B. Let's take a look at C. For C, it's going to be +6. And that's why I know my answer is C, because I can see that my oxidation number goes from +4 to +6. Is that clear, guys? And then here, it goes from -2. So it actually is oxidizing here. So it's definitely not this one. So all you have to do for this one is calculate the oxidation states of sulfur and look at which one increases in oxidation number. So the S atom has a 0 oxidation state, so it actually decreases. So this is not reduction. We can cross it out. The B, the sulfur atom does not increase in oxidation number, so it's also not this one because it's 4 and 4. And C is the only one I actually can see an increase. I can see the oxidation number goes from +4 +6. What was the one for the answer about the variable oxidation state? That was bromine, so D. All right. Okay. Next, it says, which compound is an aromatic ester? So you have to look at which ones form an ester bond. So be very careful. So an aromatic has to do with whether there's a ring. So it's definitely not C. I'm going to already cross that out, guys. But which one has an ester bond as well? This is M23 Time Zone 2. Okay, I'm getting a lot of B's. Very good, guys. So I can clearly see my ester bond. So this would be a carboxylic. So it's not this one. This one would be an ether and a ketone. Okay. And so it's definitely would be B because I can see my ester bond here. What's an ester? An ester is when it bonds like this. Okay. Hopefully that made sense. I'm going to move on. Okay. Which product could be obtained by heating the isomers of C3H8O under reflux with acidified potassium dichromate? So this is an aldehyde, this is a ketone, and this is a carboxylic. From that, which one can you guys, what can you guess that the answer is? Okay, I'm getting a lot of C's in the chat. Very good. If you guys put C in the chat, you are correct because it's actually only ketones and carboxylic acids that under reflux, those would be the only ones produced from heating them under reflux with acidified potassium dichromate, right? Because aldehyde does not do that. And I can see my screen is frozen, so I'm going to wait a couple of seconds, but it should load and show you the explanation. Someone asked, will we be doing other subjects? We did do bio already. You can find the recording on YouTube. Just waiting for my screen to load. But you guys are correct, it is C. If you put C, yes, because it would only be ketones and carboxylic acids that would be able to react. Or would be produced, sorry. Is this question HL? It's SL, so this is an SL paper. Okay. Mm, waiting a couple of seconds for my screen to stop freezing, and then we'll move on to question 26. Okay, question 26. So let's just scroll back up. I just showed you that this is an aldehyde, and therefore it would not be produced. It's only ketones and carboxylic acids that are produced. And if you guys are having a bit of trouble with this, I would suggest you review your organic chem knowledge, because it's just a matter of memorizing, right? It's a matter of memorizing what happens when I do all those chemical reactions. Okay. 26, it says, what is the preferred IUPAC name of the structure shown? So here's my structure. And while you guys are trying to answer this one, what I'm going to do is I'm going to go ahead and draw the C's, because I think that's the most difficult part of this question, is knowing when there's C bond, there's carbon atoms. Okay, what is everyone thinking? So remember, you have to look at the longest chain. I'm seeing a lot of B's in the chat. Very good. This is IB Bio, but I'm sure some of the content is similar to the AP Bio. Exactly. Very, very good, guys. It is B. And I can see my longest chain is this one here with the 4 carbon. So I know it's going to be bute. So I can already cross out my prop and my propanol here. And finally, you can see that my hydroxyl group, so this here, which makes it an alcohol, is on my second carbon. So it's on my carbon 2. Because this is my carbon 1, and this is my carbon 2. And therefore, I can cross this one out, and it's definitely B. Okay, and I can see that my methyl group, so this would be my methyl group, it's also on the carbon 2, and then my second methyl group here is on my carbon 3. Okay. Question 27. This one again is a matter of reviewing organic chem and making sure that you know every single type of those reactions. But it says, what are the most likely reactions ethene and benzene will undergo? Is this recorded? Yes, it is. You can find it on YouTube. Someone said A. Very good, guys. A. Yes, the correct answer is A. Ethene will more likely go addition reactions, and benzene is substitution. Again, if you need more help, I would suggest you review the organic unit and memorize all those steps. Take like 30 minutes of your day, sit down and draw a mind map from memory, or draw it out and like keep reading that mind map over and over again, and eventually it will get into your head. You guys are correct. It is A. Benzene undergoes substitution and ethene goes under addition. We're almost done, so we'll be done in around like 10 minutes, hopefully. We only have 3 more questions left. You guys have been doing very, very well. It says, which observation would explain the systematic error for an experiment involving the combustion of magnesium to find the empirical formula? So I'm looking for something that causes a systematic error. What does the systematic error affect? Or what is the cause of a systematic error? What I like to use is something called PRAS. So PRAS stands for precision, affects the random errors, and systematic errors are affecting the accuracy of my experiment. So it's actually the opposite way here. So my random errors affect my precision, and my systematic affect my accuracy. So what is affecting my accuracy of my experiment? Okay, I'm getting C's in the chat. A. The correct answer is C, because I can see if the crucible had black soot on the bottom after heating, that's an issue with my system. That's an issue with my experimental method, and it's not an issue of a random error. It's a systematic error. Something is wrong with my system. And because I have black soot at the bottom of my crucible here, what will happen is my fire will not be able to heat my crucible enough, and therefore um, my temperature increase, or whatever I'm measuring, or the oxidation, whatever I'm measuring, it's not going to be, the heat is not going to be directly transferred fully to my crucible because this black suit here is preventing. It acts like an insulating layer if that helps you understand it more. Does the flame color affect anything? No. Okay, does that make sense, everyone? So brass, remember, is something that affects the accuracy of my experiment. So the accuracy, because this black suit will affect my accuracy, and it is a systematic error. Something is wrong with my system. Okay. Almost the last question. We're almost there. It says the following graph shows the concentration of C4H9Cl versus time. What is the average rate of reaction over the first 80 seconds? What does PRAS mean again? So PRAS means precision. So precision is affected by random errors. So random errors cause precision errors, and systematic errors cause accuracy errors. All right. I'm going to move on for the sake of time. If you guys have any questions, I'll go back to them in the end, but just for the sake of time, because we are um, almost going a bit over time. We have two more questions left. Okay, it says the following graph shows the concentration of this versus time, and it wants you to calculate the average rate of reaction over the first 800 seconds. I'm going to give you a couple of seconds to try to answer that in the chat, and then we'll go ahead and work it out together. So what are you guys thinking the answer could be? Okay, I see a lot of questions about 28. I'll go back to 28 after the end, after I finish those, just so anyone who does understand 28 doesn't have to wait and for the sake of time. So I'm getting a lot of B's, and the correct answer is actually B, correct, guys? And why is that? Why is the correct answer B? Well, I just have to take the change in concentration. Remember, the rate of reaction is the change in concentration of um, the product or the reactant over time. And here I can clearly see the concentration is decreasing. So it goes from 10 to 8, so 0 0.8, sorry, 0 0.1 to 0 0.8 over 800 seconds. So all I have to do is 0 0.1 minus 0 0.02, all divided by my seconds, which is 800. Okay, 0 0.1 minus 0 0.02, it's going to give me 0 0.08 over 800. And what you can do is you can convert them, both of them, to the same scientific notation. Or what I like to do is I like to go and say 0 0.08 is the same thing as saying 8 over 100. Okay, 8 over 100 divided by 800 is the same thing as saying 8 over 100 times 1 over 800. And my 8s and 8s cancel out, so it's going to be 100 times 100. And clearly that shows me 1,000. And 1,000 can be written in scientific notation as this here, 1 times 10 to the negative 4. Is that making sense, everyone? Why it's B? Hopefully that makes sense. I'm just going to plug in my light because I see it went down. All right. It's very bright. Okay, so hope it makes sense why it's B. I'm going to move on to the last question. It says, which compound will only have one H NMR signal and show a carbonyl group in the IR spectrum? So which one is it going to be? I'm going to draw them out so you can see them better. And actually, so the first one is CH3. COH. Okay. The second one is going to be CH3, COOH. C is going to be CH3, OCH3 like this. And then finally, D is going to look like, let me switch colors here. D is going to look like this, which one is going to be CH3, C, CH3, C, double bond O, CH. Okay, I'm getting a D in the chat, and C, D. So be very careful that the HNMR has to do with how many hydrogen groups are bonded to carbon. So the carbon, in this case it would be the oxygen, so careful, has to be carbon. Based on that information, would you guys change your answer? So hydrogen groups all have to do with bonding to carbon. So the answer would actually be D. So if you put D, you are correct. Very good job, guys, because we can see actually, I saw that some of you put a lot of C's. We can see that it doesn't count because they're bonded to O's. And this one, it does. So this is the one, basically. This is the same as this one. And therefore, it show one peak in my HNMR spectrum because they're both bonded to the same carbon. Okay? That's different because here it's bonded to the oxygen. So it's not B for that reason. And then here it'd be one peak. And then the second peak is this one. So it's not this one. And again, one peak. And this would not even show a peak. So, oh, sorry, this one, that. Does that make sense, everyone? Hopefully that made sense. I'm gonna wait for. Yes, it is about hydrogen environments and they're symmetrical. But it has to be always bonded to a carbon. So it will be symmetrical in the option D. And I see where you get the confusion from, but it's bonded, it has to be bonded to C. Yes. Okay. Carbonyl group is COH. So which one are you referring to? So I think you mean carboxyl group? Oh, you mean for A? That would be an aldehyde. 3. So we can see the double bond is on the last C, so it's an aldehyde. Okay, so that will be it. So thank you for joining us today. I'm gonna go at, don't worry, I'm gonna answer the question in the chat. But if you do want to leave, we are done for the session. I will just put a QR code image on the sorry, I'm getting lost in my words, on the screen. And if you guys could please fill in this feedback form and tell us what more you guys want to see so that we're able to help you more with your practice. But if you want to go, you are more than welcome to go. If you want to stay back and ask questions, you can. Yeah, so if you can fill this feedback form, tell us which subjects you want, what you want us to do next. That will be very, very helpful. Yes. Okay. So take a couple of seconds. I will go back and answer 28. Okay. Thank you guys so much for joining me today. Thank you for being so interactive with me as well. What time do you start lives? Well, it depends on what people request. So there's not usually a decided time, but we always upload it on our channel when on our TikTok main page when we will go live. So if you follow that and like keep notes, I'll usually post it as an event and then you'll know time. Is this biology? This is IB chemistry. SL. Okay. Do you do biology as well? We did do a biology paper. We did do a biology paper and we posted on YouTube. So if you guys want to go watch that recording, you can. Okay. If that's all, I think you guys can see my screen, hear my notification things, and I apologize for that. The bio paper 2 is not, it's part of the crash course, but if you guys request one in the feedback form, we'll be happy to do one as well. Damn. Let me see if I can X out of this. How do I mute this? Mute site. Okay, I muted it. Okay. Anyone have any questions? Otherwise, I can go back to question 28. How do I access the crash course? On our website. So you can just sign up on our website. Okay. So hopefully you guys don't need the QR code. Just take a screenshot for later as well. The crash course is on our website, yep. So you guys wanted me to go back over question 28. Okay, so for question 28, it says, let me remove the QR code. Hopefully whoever asked that question is still here. Sorry, it took a second to go back, but we did go back to it. So the QR code is just going to be here. Again, it's for the feedback form where you can request what subjects you want, what papers you want, what year you want, and so on. So it says, which observation would explain a systematic error for experiment involving the combustion of magnesium to find the empirical formula of its oxide? So when you're actually trying to combust magnesium oxide, when you're trying to combust magnesium, you have to burn it in excess oxygen. So you wouldn't even have a crucible lid on your experiment. That's the key thing. So that's why A is incorrect. So usually A would be a systematic error. You guys are correct to assume that, but since you are combusting it, you're already breaking it down in excess oxygen, trying to find the oxide. And therefore, if oxygen entered your crucible, it doesn't really matter. It's just excess oxygen. Does that make sense, everyone? Hopefully whoever asked that question is still there. Please let me know if that makes sense. If you want me to explain it a different way, I can. Can you repeat PRAS? Of course I can repeat PRAS. So PRAS, my teacher taught it to me when I was in class, but he said PRAS stands for, so P-R-A-S. So let me move the QR code. The R stands for the random errors and how random errors affect the precision of the experiment. And then S stands for systematic and how they affect the accuracy of the experiment. So sometimes the IB will ask you, what is affected when I do a random error, when a student does a random error? And you have to say the precision, not the accuracy. And so this is kind of to help you understand which one to use. All right. Does anyone have any other questions? Hopefully I've answered question 28 well enough. But question 28A, why it's not A, it's just because, again, you're burning magnesium to find its oxide, you're combusting it. And what do we do with combustion? We burn it in excess oxygen. All right. If that's explained well enough, does anyone have any other questions? Thank you so much for joining me, guys, today. I'm going to stay back for like 5 extra minutes. And if you guys have any questions, I'm going to scroll up to see if I missed any of your questions. How do we revise for such questions? Do you mean just for paper 1 in general, or do you mean for like chemistry? Which questions are you referring to? Can you repeat PRAS? I'll repeat PRAS one more time. So PRAS stands for, basically sometimes IB will ask you, if it's a random error, will it affect my precision or my accuracy? And the way my teacher taught me to remember it is by doing that random errors affect my precision and systematic errors affect my accuracy. Is IB prep supposed to be hard? Yes, I think it is supposed to be hard. But if you're finding it easier, then lucky you. But it is a difficult process, especially because all the exams are like joined together. All right, thank you guys. Anyone have any more questions? If not, we can go for today. I hope this session was helpful. Please do fill in the QR code for the feedback form so that we know what you guys want next. All right, if that is all, thank you guys. Okay, bye everyone. I hope you have a nice evening and good luck with your study revision. If you need any help with anything, feel free to comment on one of our TikToks, and if we see it, we'll of course try to help you as best as possible. All right, bye guys.